Okay, this time let's take a look at how to do this modular project separation using Swift Package Manager. So here I'm sitting in a folder, and it has an app subfolder and a modules subfolder. If we take a look inside of app, this is essentially what we created last time with Xcode Gen, and I can just run Xcode Gen at any time to recreate my project, and I can open it up in Xcode, and we basically have an empty project. Okay, so the next thing I want to do is add a few modules that we can integrate into this project. So I'm going to go out of the app folder and into the modules folder. Now this folder that I'm sitting in right here is the root of our Git repository. So every bit of this is going to be under the same Git repository. That's not necessarily required, but it is a good idea if you're going to be doing relative paths for your module reference, which I'm going to do in this episode. If you're going to decide to publish your modules as their own private Git repos with their own versioning schemes and things like that, certainly a direction you could go in, but I would suggest to start with path-based modules to start with, and then eventually graduate up to, treating modules as their own separate projects entirely. So let's go into modules, and we're going to use Swift Package Manager to create our different modules. So the first one I'm going to make is called the util, and it's the most basic module that we had. And so I'm going to cd into that folder, and we're going to use Swift Package init --type equals library. And if I look in sources, util, we should have util.swift. We should be able to run Swift builds in order to build it. And the build is complete. And I'm just going to open this up in Finder real quick. And I'm going to drag in our helpers that we used from last time. So we're going to put that into util helpers like this. And that was our date extension type, which at this point is just an empty extension, but it serves as our most basic introduction into this modularization. So if I run Swift build again, it should include that file. And let's open this up in Xcode. Xcode seems to be a bit confused, so I'm going to quit it and reopen it. Okay, now we can see we've got a Swift package. You can see by this icon here. We can manage our package.swift right inside of here and see exactly what it generated. We can get rid of some of the comments that we don't really need. This one will have no dependencies. And for the targets, you can see that it just has the util target, which is our framework, and the util tests, which is our test target. And if we want to run the tests, we can run it with Command U from within Xcode, and it should pick up this util tests and actually run this. And if we want to run it from the command line, which is something I do a lot, which you can run Swift build to build it and Swift test to test it. Now, I think it's really important to embrace the automatic command line builds of these individual modules and to write some at least rudimentary tests to make sure that your modules compile and the tests run independently of each other. And that's useful because sometimes you might be zeroing in, working on just one module, not realizing that you accidentally made a breaking change in something that depends on it. And by having this automated in a way that you can run a script or a series of scripts to verify that you haven't broken anything before pushing, because not everything may live in the same Xcode project. Okay, so now we have a util package. It's not very useful, so I'm just going to really quickly create another one called core, which is going to contain our models. Okay, so now we can see I've got my core package. I can clean up a bit of this that we don't need. This one will also have no dependencies. Okay, so that's our core, and it contains models, which if we expand this out, we've got our meal and our meal type. And then we also brought in our models tests, which will test, well, there's nothing really of value in here, but this is where we could write tests for our models if we wanted to. Ultimately, these will pass, and so we can run Swift test here to make sure that that works. So at this point, we've got two packages. Both of them have a package.swift. We can open them up in Xcode without managing our own Xcode project, and we can do Swift build and Swift test from the command line. All right, we're going to create one more module, and this one is the store, and the store is a bit more involved. So let's create our store, cd into it, and we can run Swift package init, type is library. Again, I will open this up here, and we will start putting in the stuff that we had from before. So in this case, we've got meal store and storage go in here. And then for our tests, we had meal store tests, which can go in there. Okay, so this one basically is empty as well. And then we've got our types here. And let me open this up in Xcode. So if we look inside of this one, we've got meal store, for instance, and meal store is looking for this type meal and this framework, or this module called core, but it doesn't have it. So this is where we need to open up our package.swift and we need to add a reference to that package. So if we go over here to dependencies, we can see this is where we add .package dependencies, and we can pass in a URL if it's a remote package, or we can use a path. And in this case, it's going to be /core. So then I can delete this, and then we can go down to our targets, and we need to tell that our store has a dependency on one of those packages. And there's the dependencies. I'm not sure if we can just say core like this. We probably need to, actually, before I do that, I want to address this error that we see here. We wrote this code with the intent of using it on iOS only for now, and we used the ISO 8601 date strategy, and that is only available in macOS 10.12 or newer. And we've never specified what platforms our application can actually run on. So this is where we would come up here and we'd say platforms in our package, and we could say, okay, this is supported on macOS maybe 13.0 and greater. It depends on what we want to say there. And then we can say iOS 13.0 as well, maybe something like that. Okay, so at this point now it lets us build because we've said we specify that as our platform. But the reason why we got that error in the first place is that it chose to run this as a Mac application here. And we'll also see a similar thing there. If we do a Swift build from the command line, we are not telling it what platform to build for. And so by default, it's going to do the same thing Xcode did and try to build it for Mac OS. But as of, I believe, Xcode 11, we can actually run Xcode build on a Swift package even without a project file by just specifying the scheme, which is the same name as the store. And then all of the different things we can do for Xcode build, we can do as well. So for instance, we can check out and say show destinations, and now we can see that there's different destinations we can choose, and these are simulator versions and things like that. Okay, so if we really want to specify what destination we want to run at, we will say destination and pass in a long string here that says platform equals iOS simulator, comma, OS equals 14.5, comma, name equals iPhone 11 Pro. So this specifies very specifically what we want to build for, and it will do the rest of the work for us. So that's how we can make sure that we build things the right way. And if we want to, we probably just add a quick command line script to do just that. In fact, let's go ahead and do that. I'm going to take this and let's just take that command and we will echo that entire thing into build.sh. And here this will be bin bash set-e, and then we can chmod +x to make this executable, and now we should be able to run build.sh, which should run it with the very specific destination that we've chosen. Okay, so now we've made our lives a little bit easier for running this build in the future. We now have 3 modules, and now let's take a look at how we can integrate these into our application. If we go over to app and we open it up, here we have our standard Xcode with a project file. We go up to the project and we choose Swift packages. This one doesn't let us enter local package references as far as I can tell. This seems like it's always a URL that we need to add here. And that's the same if we use the file menu to import packages. So what we're going to have to do is tell Xcode to generate the project with those package references. And we can do that with Xcode Gen's project.yaml file. So here, right underneath options, we're going to say packages, And here we can specify each package that we depend on. So we can say util is .. modules / util. And we can say core is .. modules / core. And we can do the same thing here for store. And those are the 3 packages that we depend on. Let's write and quit, and then we will run Xcode gen again, which should create our project and create our packages. So if we take a look at our project now, we've got a group here called packages, and it has a reference to each one of these. Okay, so if we want to actually use this, let's just go over to our app delegate. Now we have this import core. Let me just do a clean and build. At this point, it's complaining no such module core. We also have store. And so maybe during launch, we might say, let's get a meal store, which is meal store. And here we can pass in our storage in memory, and we can pass in our calendar, and our send notification block can just be empty. Okay, so now we've got a meal store, and I can say meal store.add, and I can create a new meal with a name of pizza, today's date, and a meal type of dinner. Okay, so we can see that we have no such module core. It's also going to fail to import store. And we could go over here to our build phases and add this as the dependency. But again, we want to manage this in a repeatable way with our Xcode project, Xcode gen project YAML file. So we've got our packages defined here, which means they will be pulled in when we open Xcode. But we do need to specify that our application target depends on those. So somewhere here in the app target, let's go ahead and add in a dependencies section. And this is where we could do things like you have an SDK dependency on, I don't know, core location or something like that. But there's also package dependencies. So here we can say we have a package dependency on util and core and store. And if we run Xcode gen again, now we can open this back up and do a build, and the build should succeed now. And now we are able to use the types that are inside of these different modules in our app delegate, and everything seems to be connected up and working. So there's more things to cover here, but for now, this is the basic structure of how to set up your packages as individual modules living in their own folders and bring them all together using Xcode gen in a main application.